discussed in the last class. Who designed heat engine? Carnot designed the heat engine. Efficiency of the heat engine also discussed, it seems. Efficiency 1 minus T2 by T1. Okay. Refrigerator is simply the device whose process is exactly reverse of heat engine. Refrigerator is the reverse of heat engine, simply the device in which the process is reverse of heat engine. Refrigerator. It also consists of the same parts. Source, working substance, and sink. Same parts. Source, which is at high temperature. Sink, which is at low temperature T2. And here a gas or something mixture of gas and liquid, working substance. Working substance. Same. See, in refrigerator, what is source and what is sink? The chamber of the fridge, the compartment of the fridge. In our houses, we use the fridge, right? In that we keep some material to keep them cool. That compartment of the fridge acts like a sink. So what is sink practically? Compartment of fridge, right? Is sink. What is source? Surroundings. Acts like source. In case of refrigerator, the compartment of the fridge acts like a sink and surroundings acts like source. Here what happens? Here see carefully. If this is the compartment, in the compartment we keep the bodies which wanted to be cool, right? Which have to be cool. When the bodies becomes cool, whenever before keeping in that compartment, they are at room temperature. We keep them here. Whenever we keep them here, they become cool, we are telling, whenever we keep the objects in fridge compartment. When objects become cool, whenever we take the heat from the objects, right? So here from the sink, heat is taken by the working substance. Here also it is taken as Q2. Heat is taken by working substance Q2 by using some machine, because we know heat cannot flow directly from lower temperature to higher temperature. It sucks the heat by using some machinery, right? Then this heat it takes from the sink. This working substance takes heat from the sink. It extracts heat from the sink in the problems we find. It takes the heat. Then after, it has to give the heat to the source. It has to give out to the environment. But this source is at very high temperature. Whatever heat taken from this is not at high temperature. Comparatively with this, the heat here is less Q2. By itself, it cannot flow. For that, what you need? We need to do work on it. So this is some system, some working substance means gas or something. In the fridge, where it is? In compressor, there is a device called compression stays. Whenever that gas, whatever heat taken from this, taken by this gas, which we call it as working substance, it has to give out that heat to the source. Whenever we compress it, we are compressing, means what? Work is done on, work is done on the gas, done on the system, done on the working substance, means compression. Whenever compressed, it gives out heat forcefully. Then it gives out heat Q1 to the source. You understand that? It extracts heat from the sink. Which one? Working substance. Then work is done on the working substance. Then it gives out heat Q1 to the source. What is source? Environment. The room in which we keep the fridge, that is environment. Then it gives out heat to the environment. But heat cannot flow by itself. That is why we use a compressor. Compressor to use, you must compress. Compress means you should do work. So work is done on the working substance, right? It gives out heat. Q2 plus W is equal to Q1. Can I write? This Q1 is greater than this Q2. So from here, Q2 plus W is equal to Q1. Then work done W Q1 minus Q. Okay. What is Q2 here? Heat extracted from sink. Sink in the sense what? Practically compartment of the fridge. And what is Q1? Heat given out to what? Source. Source means practically what? Environment, surroundings. Sink means compartment. Source means surroundings. So the relation is this: Q2 plus W is equal to Q1. W is equal to Q1 minus Q. Well, here in case of refrigerator, we calculate coefficient of performance. Coefficient of performance. Coefficient of performance means represented with beta. What is the formula? Q2 by W. This is the formula for coefficient of performance. Q2 by W. W can be written as Q1 minus Q. So Q2 by Q1 minus Q2. In another way, in terms of temperature, if you are asked, T2 is proportional to Q2, T1 is proportional to Q1. Then how can we write that beta? Beta is T2 by T1 minus T2. This is coefficient of performance, right, of the refrigerator. See this beta value, how it is? It is always greater than 1. Beta value is always greater than 1. Quotient of performance is always greater than 1. Practically, this value lies in between 2 to 6. Practically, beta value of any refrigerator lies in between 2 to 6 wherever T limits come. 2 to 6. And percentage of beta always greater than 100%. And beta never be equal to infinity. Greater than 1, okay, but never be infinity. But in the last class we see efficiency. Efficiency is always less than 1. You write there? No, write down. Efficiency is less than 1. Percentage of efficiency less than 100% always. Never be 100%. It is always less than 100%. Coefficient of performance is greater than 1. Efficiency is always less than 1. Okay. What is the relation between neta and beta? Relation between neta and beta. Neta is efficiency. Beta is coefficient of performance. See, same setup. If you reverse it, it acts like heat engine. See, heat engine is operating between the temperatures T1 and T1, T1 and T2. Between the same two temperatures, refrigerator, it worked as a refrigerator. When it works as a heat engine, efficiency is neta. When it works as a refrigerator, coefficient of performance is beta. What is the relation between neta and beta? Can we derive? See, in the exam, they give the question between the same two temperatures. Between same two temperatures, T1 and T2. When it acts like a heat engine, efficiency is neta, right? Between the same two temperatures, acts like a refrigerator. Acts like a refrigerator. Coefficient of performance is beta. What is the relation between that neta and beta? What is the relation between neta and beta? Neta formula is what? 1 minus. You have this formula? Emma. Beta formula is what? Okay. From this, T2 by T1 1 minus neta you can write. Racha? Iman. Okay, from this 1 by beta is equal to what you can write? T1 minus T2 by T2. T1 by T2 minus 1. Can I write? Okay. Then what I get? T1 by T2. 1 by minus 1. So what it gives? 1 minus 1 plus neta by 1 minus neta. 1 get cancelled. Then 1 by beta neta by 1 minus neta. That's it. That is the relation between beta and neta. If it goes up, minus of minus plus. So beta is equal to 1 minus neta by neta. Next, even if you want, you can write beta in terms of beta. You can write from that. Next, see, in a refrigerator, sink chamber, in the sink chamber, I place a water bottle. I place a water bottle of some mass m. Let some material, water bottle, let us say, of mass m, which is initially, before keeping it, its initial temperature, let some T1 degree Celsius. T1 degree Celsius, initial temperature. I placed it in to cool it to 0 degree Celsius. From T1 degree Celsius to 0 degree Celsius, I want to cool this water. For that, what I did, I keep it in the fridge. Okay. So in refrigerator, what happens? As it is a sink, heat extracts from this Q2. How much heat extracts? For that fridge, they give coefficient of performance. Coefficient of performance of the fridge they give. Coefficient of performance of the fridge is beta. Okay. Work done is W. Work done is W. You are asked to find this work done. How much work to be done to extract heat to cool this water bottle, this water from T1 degree Celsius to 0 degree Celsius? This is the question. A water bottle I kept in. Initially it is at T1 degree Celsius. I want to cool it to 0 degree Celsius. How much of work to be done? This is the question. Its coefficient of performance is beta. See, for beta, what is the formula? Beta is equal to Q2 by W. You are asked W. Okay, beta they give. They have a value. Q2 is what? Q2 is the amount of heat extracted to cool it from T1 to 0. What is the amount of heat it lost? How much amount of heat it lost? Q2. Then the change of temperature. Then amount of heat lost. M S delta T. Now, if I can write with J. Why I am writing J? Generally the problem they give M in grams, S in calorie per gram degree Celsius, delta T, change of temperature. So Q2, J MS delta T. Then what is the work done? So how to write beta now? Beta is equal to Q2 J M S delta T by W. Okay. What is M there? What is M? Mass of the water to be cooled. What is S? Specific heat of water. And delta T, change of temperature. Come on, write down. A regular problem. Next. There is a regular problem. See, there are two engines. This is T1, T2, T3. This engine is operating between T1 and T2. Okay. Here is working substance. This is one heat engine. Heat engine 1. This is heat engine 2. And this engine is operating between T2 and T3. T2 and T3. Okay. For this engine, efficiency is neta 1. For this engine, efficiency is neta 2. First engine is operating between temperatures T1 and T2. This second engine is operating between temperatures T2 and T3. For the first engine, efficiency is neta 1. For the second engine, efficiency is neta 2. Okay. Then, what is the efficiency of the engine? Heat engine, which is operating between T1 and T3, which is operating T1 and T3, efficiency is neta 3. I want a relation between neta 1, neta 2 and neta 3. These are given in the problem. What is the relation between this neta 1, neta 2 and neta 3? Okay, come on. See, whenever it is operating between T1 and T2 for the first engine, tell me what is efficiency formula? Neta 1 is equal to 1 minus T2 by T1. From this, T2 by T1 is equal to T2 by T1, 1 minus neta 1. For the second heat engine, neta 2, what it is? 1 minus T3 by T2. Is it okay? T3 by T2 is equal to 1 minus neta 2. Then for the third engine, neta 3, 1 minus T3 by T2. Yes or no? T3 by T1. Well, come on. From this, T3 by T1 is equal to T3 by T1, 1 minus neta 3. Okay? Then, see, T3 by T1, 1 minus neta 3. There it is. Can I write it as T3 by T2 into T2 by T1? T2 get cancelled again. I get T3 by T1. 1 minus neta 3. Okay. T3 by T2, 1 minus neta 2. T2 by T1, 1 minus neta 1. This is 1 minus neta 2 into 1 minus neta 1. This is 1 minus neta 3. This is the relation. Then I want neta 3. Neta 3 is equal to 1 minus of this total on that side. This neta 3 comes on to this side plus and it goes on to that side minus total. 1 minus neta 1 into 1 minus neta 2. That's it. Completed? Right, one problem. A Carnot's engine whose efficiency is 40%. A Carnot's engine whose efficiency is 40% takes heat from a source, maintained at a temperature of 500 K, maintained at a temperature of 500 Kelvin, maintained at a temperature of 500 Kelvin. It is desired to have. It is desired to have an engine of efficiency 60%. Then it is desired to have an exhaust temperature of efficiency 60%. Then what is the intake temperature? What is the intake temperature for the same exhaust temperature? What is the intake temperature for the same exhaust temperature? What is the intake temperature for the same exhaust temperature? First, what is given? When T1 is 500 K, okay? T2 I don't know. Efficiency is what? 40%. Yes or no? Okay. Second case, for the same exhaust temperature, whatever it is, here also, what is the intake temperature? What is the intake temperature means? T1. Exhaust means giving up, sink temperature. To have an efficiency 60%. That is the question. How to solve? See, from these data, can you find T2? Neta is 40%. Means what? 40 by 100. 40 by 100 is equal to 1 minus T2 by T1. Is it okay? From this is 2 by 5 is equal to 1 minus T2 by T1. Then I want T2. Then T2 by T1 is equal to T2 by T1. 1 minus 2 by 5. This is 3 by 5. Okay. From that, what is T2? T2 is 3 by 5 into 500. This is 300 Kelvin. Okay. I got T2. For the same exhaust temperature means T2 is 300 only. From that I got. What is intake temperature? To have an efficiency 60%. You can calculate. Okay. See, efficiency 60% means 60 by 100 is equal to 1 minus T2 by T1 dash. You are asked to calculate T1 dash. Calculate. How much you got? $750 you have to get. See, if you calculate, you get T1 dash is equal to 750 Kelvin. Calculate and see. Next one. A refrigerator down the next problem. You try this. A refrigerator whose coefficient of performance beta is given as 5. For a refrigerator, coefficient of performance beta is given as 5. Extracts heat from the cooling compartment at the rate of 250 joule per cycle. It is extracting heat from the cooling compartment at the rate of 250 joules per cycle. Heat from the cooling compartment means what they are giving? Q2. Heat from the cooling compartment. It is a refrigerator. Q2. The first question asked is, what is W? Second question asked is, how much heat it gives out to the room? What is the work done per cycle? And how much heat gives out to the room? Two questions. Then, to find W, there is a relation between these three? Okay. Beta is equal to Q2 by W. Then, W, Q2 by beta. What answer? 250 by 5. Okay. 50. Then Q1 I want. Q1 is what? Q1 is always W plus Q2. Yes or no? In the refrigerator, you just observe. W 250, Q2 50, 300 joule. Next. Given that a Carnot engine having an efficiency, 1 by 10, a Carnot engine having an efficiency 1 by 10 as a heat engine. When Carnot engine acting like a heat engine, efficiency is 1 by 10. Then, when it is used as a refrigerator, when used as refrigerator, the work done per cycle is 10 joule. Work done per cycle is 10 joule. They ask, what is the amount of heat absorbed from the cool reservoir, absorbed from the sink? That is the question. First, when it is acting like a heat engine, neta is 1 by 10. When acts like heat engine. When it is turned into a refrigerator, this is the work done on the system. What is the heat take from the cool compartment, from the sink? Okay. To calculate this Q2, what is the formula? Beta to be known. Emma, beta is equal to what? Q2 by W. But here beta is not given. What is given? Neta is given. You have a relation between neta and beta. So beta is what? 1 minus neta by neta. Okay. Is equal to Q2 by W. Substitute. You'll get the answer. 1 minus 1 by 10 by 1 by 10. Q2 you have to find by 10. See, this is 9 by 10 by 1 by 10. Q2 by 10. 10, 10. Get cancelled. Q2 is 9. Next. Next. Generally, Carnot heat engine we are using. The ideal heat engine is what? Ideal heat engine is Carnot's heat engine. In which type it is? It is a reversible heat engine. Carnot heat engine. Reversible heat engine. It operates in reverse cycle, in a cyclic process, reversible cyclic process. Okay. But in practically, all heat engines are operating irreversible cyclic process, right? Practically, all heat engines operate. Heat engines are irreversible cyclic. Irreversible cyclic process. They operate. Always efficiency of reversible cyclic engine is greater than efficiency of irreversible between the same temperatures. So always efficiency of the Carnot engine is greater than efficiency of any practical engine. Right? In theory bits it is possible. When two engines are operating between same temperatures. One is Carnot's reversible engine, another one is irreversible engine. Which has more efficiency? Reversible engine has more efficiency. So what is second law? Second law of thermodynamics. There are different statements, but simply what second law says is total heat cannot be converted into work. This is first statement. Simple, I am telling you. No engine can convert, no machine can convert total heat into mechanical work. Total heat cannot be converted into work by any machine, right? This is first. Total heat from a body, you cannot extract the total heat from a body till the temperature lower than the surroundings. The exact meaning is that total heat cannot be converted into work by any machine. Second, heat cannot flow by itself. heat cannot flow by itself. From the region of high temperature to region of low temperature. Sorry, from the region of low temperature to the region of high temperature. Reverse. We know heat flows from high to lower. Can it flow from low temperature region to high temperature region by itself? No, it is not possible. When it is possible? By using an external agency. In the refrigerator, we are doing the same. Using some machine, by external agency like compressor, some machine, it is possible. By itself, it is not possible. Right? These are the simplest forms of second law of thermodynamics. It tells about direction of flow of heat. Second law tells about what? Direction of flow of heat. And it gives the limitation. How much of heat can be converted into work? This is something about second law. Okay, we discuss tomorrow.